A single piece of crystal may have guided Viking ships across the open ocean. We are going to unravel the enigma of the Viking Sunstone, and by the end, you will understand how a simple mineral could rewrite the history of exploration. How did navigators find their way under perpetually cloudy skies, and what secret did they hold in their hands? What does it feel like to place your trust in a stone when the entire sea is your only map? The North Atlantic was a world defined by its hidden horizons. For months at a time, the sun could become a distant memory, smothered by a seamless gray ceiling of cloud. The sea itself shifted from a sparkling blue to a menacing iron gray, its waves capable of swallowing whole ships. This was the arena the Vikings chose for their most audacious journeys. In vessels we would consider terrifyingly exposed, little more than elegant wooden shells, they set out across thousands of kilometers of open ocean. Their destination was not a coastline they could see, but a coastline they had to believe was there. They sailed toward Iceland, a land of fire and ice, then further west to the stark shores of Greenland, and finally to the wooded coasts of a continent they called Vinland. All of this was achieved without what we consider the most basic navigational instrument, the magnetic compass, which would not arrive in Europe until centuries later. This gap between what they accomplished and the tools we know they had is the central mystery. It is a void in our understanding that demands an explanation. Their success was too consistent, too deliberate, to be attributed to luck or blind courage alone. It whispers of a system, a method of reading the world that was so intuitive to them, it left barely a trace in the sagas. The legend of the Sunstone emerges not as a fanciful myth, but as a potential key to this very real, very practical problem of survival and discovery. To grasp why a crystal could be so revolutionary, we must first feel the immense scale of their challenge, navigating a featureless seascape under a perpetually hidden sky. The answer to this navigational mystery lies not in physical artifacts, but in ancient stories. To find the Sunstone, we must first listen to the echoes of the sagas. These Icelandic narratives, written down centuries after the Viking Age, are our primary window into that world. They are not technical manuals, but rich tapestries of adventure, family feuds, and kings, where moments of practical reality shine through the poetry. One saga in particular, the tale of Hroðulf's Þátr, offers our most compelling clue. In a scene set during a harsh, cloudy winter, the Norwegian king is troubled. He needs to know the sun's position to settle a matter of timekeeping. The text states that a man named Sigurður held up a solarstein, a sunstone, toward the sky, and by its guidance, he correctly declared where the sun would be. This is not a dramatic scene of ocean navigation, but a quiet, almost mundane moment of problem-solving. It presents the sunstone as a known object, a tool with a specific function, used to find a hidden sun. This casual mention is what makes it so tantalizingly believable. If it were a central magical artifact, it would be described with more fanfare. Here, it is simply a thing that works. Yet, this single reference is a fragile thread. Was the solarstein a common piece of a navigator's kit, as practical as a sail needle, or was it a rare, precious object, perhaps owned only by kings and chieftains? The sagas do not say. Furthermore, we must remember these stories evolved through generations of oral telling before being written. Details could be added, altered, or lost. A storyteller might describe a tool from his own time, projecting it onto the heroic past. So we are left with a beautiful, frustrating puzzle. A clear, functional description exists, but it is isolated, wrapped in layers of literary tradition. This forces historians to become detectives, carefully separating plausible historical fact from the powerful embellishments of legend. They look for consistency, for echoes in other texts, for any scrap of evidence that this was more than a metaphor. The search moves from the pages of vellum to the very laws of light itself, asking if such a tool could even exist in the physical world. The Sagas give us a name, but physics must give us a substance. If the sunstone was a real tool and not a poetic device, it had to be made of a real mineral, one with a very specific and rare ability. The search narrows to a fascinating family of crystals that interact with light in an extraordinary way. When sunlight passes through our atmosphere, it becomes polarized, meaning its waves vibrate in a particular direction. This is invisible to the human eye, but not to certain crystals. They can filter this polarized light, creating visual cues a trained observer could interpret. 3 geological suspects emerge from the evidence, each with a compelling case to be the legendary sunstone. The first is cordierite, often called Viking's compass. This stone has a unique property called dichroism. When you look through a clear piece of cordierite and rotate it against the sky, its color changes from a pale yellow to a deep, inky blue depending on its alignment to the hidden sun's position. It acts as a direct visual indicator. Geologically, it is found in Scandinavia, meaning it would have been accessible. Its color-changing magic is immediate and requires no complex understanding of optics, just careful observation and remembered patterns. It feels like an intuitive tool, something a navigator could learn to read through years of experience. Then there is tourmaline, another dichroic crystal with similar light-filtering abilities. However, its case is weaker. While it exists in the region, it is less common in the clear, large pieces needed for such a precise task. The third, and perhaps most famous candidate, is Iceland spar, a perfectly transparent form of calcite. This crystal does something different and even more precise. It exhibits birefringence, meaning it splits a single beam of light into 2 separate images. If you hold a piece of Iceland spar up and look through it, you see a double image of whatever is behind it. By rotating the crystal and observing how these twin images change in intensity against the polarized sky, a user could pinpoint the sun's location with remarkable accuracy. Its clarity is legendary, and we know it was mined in Iceland and traded across the Viking world. Centuries later, it became crucial for understanding light polarization itself in scientific experiments, proving its unique properties were real and potent. So which crystal fits the story best? Cordierite offers beautiful simplicity, a tool of immediate visual feedback. Iceland spar offers sophisticated precision, a tool of subtle science. The availability of both in the Norse world makes them strong contenders. The choice may not be a single answer. It is entirely possible that navigators used whatever suitable crystal they could acquire, mastering its particular language of light. A captain from Norway might swear by his piece of cordierite, while an Icelandic trader might trust his flawless chunk of Iceland spar. The principle remained the same, a secret conversation between sky, stone, and human skill. But a principle is not proof. To move from compelling theory to historical fact, we need to find one of these sunstones in the one place it would be undeniable, resting beside a Viking navigator. The sky holds a secret map written in light itself. To understand how a simple crystal could reveal the hidden sun, we need to grasp a beautiful, invisible phenomenon, polarization. Imagine sunlight as a wave, vibrating in every direction as it travels from the sun to your eyes. But when that sunlight scatters through the molecules of our atmosphere, something changes. That scattering process acts like a filter, organizing the chaos. It causes the light waves to vibrate more strongly in one particular plane, creating a pattern of polarized light across the entire dome of the sky. This pattern is centered on the sun, even when the sun is completely obscured by clouds. To our unaided eyes, this polarization is utterly invisible. The cloudy sky just looks uniformly gray, but to certain crystals this hidden pattern is as clear as text on a page. Minerals like cordierite or Iceland spar have a crystalline structure that acts as a gatekeeper for light. They only allow light vibrating in one specific direction to pass through easily. Think of it like trying to shake a rope through a narrow, vertical slit. If you shake the rope up and down, it passes through. If you shake it side to side, the slit blocks it. The crystal is that slit. A Viking navigator would hold such a stone up to the overcast sky and slowly rotate it. As the crystal turns, its internal gate aligns with different parts of the sky's hidden polarization pattern. At one specific orientation, the crystal will appear darkest because it is blocking the most light. That point of maximum darkness reveals the axis of the polarization pattern, which forms a great arc across the sky pointing directly to the sun's position. It is a physical needle in a celestial haystack. By taking a second reading in a different part of the sky, the navigator could cross these two invisible lines and pinpoint the solar azimuth, the sun's bearing along the horizon, with surprising accuracy. This was not magic. It was a sophisticated, hands-on application of optics, a way of using the fundamental properties of light as a tool for survival. The genius lies in its simplicity. The navigator did not need to understand the physics of electromagnetic waves. He only needed to know the ritual, to observe the stone's response, and to trust the consistent language of the sky. This transforms the sunstone from a mythical object into a plausible, even elegant piece of technology. It turns the overwhelming gray void of an overcast ocean into a structured space with a hidden center. But knowing the sun's position is only half the battle. It tells you direction but not your location. For that, the Vikings needed another layer of ancient knowledge, a way to use that single bearing to chart a course across a trackless sea. Knowing the sun's bearing is a vital piece of information, but it is still just a single, fleeting point of reference. To cross an ocean, you need a system. You need a way to take that momentary reading and lock it into something tangible, something you can consult again and again as the hours stretch into days. This is where theory meets the workshop. Historians and experimental archaeologists believe the sunstone was likely just one component in a more complete navigational toolkit. They propose it was used in tandem with a simple, ingenious wooden device, often called a horizon board or a shadow board. Imagine a flat plank of wood, perhaps marked with concentric circles or simple lines. At its exact center, a small, vertical peg, a gnomon, is fixed. Here is how the system might have worked. On a cloudy day, the navigator first raises his sunstone. He rotates it slowly against the gray sky, watching for that telltale darkening that reveals the hidden sun's azimuth. He now knows the sun's general direction. He then takes his horizon board and physically rotates the entire board so that the central gnomon's shadow, cast by the diffused light, falls directly along a line pointing toward that bearing. At a specific moment, perhaps local noon when the sun is at its highest, he marks the precise tip of that shadow on the board. This single mark, created on an overcast day thanks to the crystal, now gives him a true north-south line. It transforms an optical observation into a permanent, physical reference etched in wood. This combination is elegant in its practicality. The sunstone finds the hidden signal, and the horizon board records it. The board could then be used for hours afterward to check the ship's heading, even as the clouds thickened or twilight began to fall. It turns a clever trick with light into a repeatable, mechanical navigation system. It provides a constant amidst the chaos of the sea. Think of it as an early, analog computer where the crystal was the sensor and the wooden board was the memory. This method requires no written tables, no complex mathematics, just careful observation and a deep, practiced understanding of the sun's daily arc across the sky. It is a technology born from necessity, carved from wood and shaped by crystal, designed to outwit the very elements that sought to obscure the way. Yet, even with a reliable method for finding direction, a Viking ship still faced the immense challenge of knowing its position. For that, they would have relied on a different kind of knowledge entirely, a living science passed down through generations of sailors who learned to read the language of the sea itself. A tool is only as good as the trust you place in it. For a Viking navigator setting out into the grey unknown, absolute confidence in his sunstone was not a luxury, it was a matter of life and death. This trust was not born from blind faith, but from a deliberate, ongoing process of calibration. Before any open ocean crossing, a navigator would have practiced his craft in familiar waters, using clear days as his classroom. On mornings when the sun hung visible in a bright sky, he would first note its position with his own eyes. Then he would raise the crystal. Rotating it slowly, he would watch for the telltale darkening, confirming that the stone's secret signal matched the reality he could plainly see. This repetition was crucial. It built a mental library, teaching his hands and eyes the precise feel of a correct reading. He learned how the crystal behaved at dawn versus midday, how its signal might shift with the seasons. Each clear day was a lesson, transforming the abstract principle of polarization into a personal, tactile skill. But calibration did not end at the harbor's edge. As a ship coasted along familiar shorelines, the navigator had another powerful reference, the land itself. Imagine sailing past a distinctive, unmovable mountain peak or the unique entrance to a deep fjord. These were natural monuments, fixed points on a mental chart. The navigator could take a bearing on that landmark using the sunstone, noting the crystal's reading. He could then compare that bearing to the known position of the landmark from his accumulated experience. Did the stone's direction line up with where that mountain should be? This constant cross-referencing acted as a real-world check. If the readings consistently aligned, his confidence in the tool grew. If something seemed off, it prompted him to recheck his technique, consider the weather, or question his assumptions. This was not a one-time setup, it was a lifelong conversation between the sailor, his stone, and the world. Through this process, the sunstone ceased to be a separate object. Its readings became woven directly into the navigator's seasoned intuition. The data from the crystal merged with his memory of currents, his knowledge of bird flights, his feel for the swell of the waves. The stone did not replace this deep ocean literacy. It augmented it, providing a reliable thread of celestial orientation that he could grasp even when every other visual clue had vanished. This synthesis of technology and tradition is what made the system so robust. It was science in the most practical sense, a method of verification and adaptation that turned a clever optical trick into the beating heart of transatlantic exploration. Yet, even with a perfectly calibrated tool and profound skill, the ocean presented one final, brutal test. A test where the sunstone would fall silent and the navigator would have to rely on something far more ancient. A broken piece of wood found half a world away from the Sagas would finally give the sunstone theory a physical anchor. In 1948, archaeologists working at the site of a Norse convent on Uunartoq Island in Greenland uncovered a curious artifact. It was a fragmented wooden disc roughly the size of a person's hand. At first glance, it might have been mistaken for a simple lid or a child's toy. But upon closer inspection, its surface told a different story. Etched into the wood was a series of precise, radiating lines, and at its very center was a carefully drilled hole. This was not a random object, this was a tool. Known today as the Uunartoq disk, it is widely interpreted by researchers as a bearing dial, a type of sun compass. Here at last was a tangible piece of the Viking navigational kit, weathered by centuries but still whispering its purpose. The central hole is the key. Scholars believe a small pin or gnomon would have been inserted there, When placed in sunlight, this pin would cast a shadow across the etched lines. By aligning the disc so the shadow fell along a specific line, perhaps one marked for a particular time of day or a known sailing route, a navigator could establish a true bearing. It is the horizon board we imagined made real, but the Uunartoq disc holds even deeper secrets. Some of its markings are not straight lines but gentle curves. These curves appear to chart the changing path of the sun's shadow throughout the day, accounting for the drastic shift in the sun's arc across the sky at different times of the year. This sophistication suggests it was not a generic tool, but one calibrated for use in high latitudes, specifically for the long, looping days of the Arctic summer. This is where the discovery becomes truly electrifying in the context of our mystery. The convent at Uunartoq was not just any site. It was located on the very sailing route between Iceland and the Norse settlements in Greenland. This disc was found exactly where we would expect a vital navigational instrument to be, at a waypoint on a perilous ocean crossing. Could this be the missing physical counterpart to the Sunstone? The integration is elegantly practical. On a cloudy day, a navigator would use his sunstone to locate the hidden sun and determine its azimuth. He would then take his Uunartoq disc, insert its central pin, and orient the entire disc so that the pin's faint shadow, cast by the diffuse cloud light, aligned with the bearing he derived from the crystal. Once set, the disc becomes a fixed reference. Even if the clouds thickened further, the disc now held the correct orientation locked in place. The navigator could simply glance down at the wooden dial to check his ship's heading against the etched guide, a constant reminder of the true direction pulled from an invisible sky. This combination tackles the two great challenges of open ocean travel, direction and time. The disc provided a steady directional reference, while the changing length and angle of the shadow over the hours could have offered a rough sense of longitude, of how far east or west they had sailed during the endless summer daylight. It represents a fusion of technology, a hybrid system where an optical crystal communicated with a mechanical dial. The Uunartoq disc does not prove the Sunstone existed, but it proves the Vikings used precise, scientific instruments for solar navigation. It shows they were thinking in terms of tools that interacted with the sky's geometry. Finding a sunstone beside such a disc would be the ultimate archaeological confirmation. But even alone, the disc transforms the sunstone from a solitary legend into a perfectly plausible component in a sophisticated and very real navigational method. But could such a system actually work on the open ocean? Legends and wooden discs are one thing, but the true test lies in the water. To answer that, we turn to a remarkable field of study, experimental archaeology, where researchers don't just read about history, they attempt to relive it. The most famous test of the Sunstone theory took place in 2013, when a team of scientists and sailors embarked on a unique voyage. Their mission was not to cross the Atlantic, but to perform a controlled, scientific experiment under real conditions. They used a replica Viking longship and a carefully crafted piece of Iceland spar, the clear calcite crystal. Their goal was deceptively simple: to see if a person could accurately determine the sun's position on a completely overcast day while standing on the deck of a moving ship. The challenges were immense from the start. The crystal's signal is subtle, a slight darkening or a shift in the clarity of a double image. On land, with a steady hand, it is difficult enough. On the water, every wave introduces motion, rocking the horizon and the navigator's own body. The sky is not a static gray canvas. Its light conditions change with the thickness of the clouds, the time of day, and the moisture in the air. The researchers had to learn the language of the crystal from scratch, developing a technique of holding it steady, rotating it slowly, and training their eyes to detect the faintest change in contrast. They sailed for days under deliberately chosen cloudy skies, taking hundreds of readings. After each crystal observation, they would immediately check their bearing against a modern digital compass, a truth-telling device the Vikings never had. The results were compelling. Even with novice users, the Iceland spar allowed them to pinpoint the sun's azimuth with an accuracy of within a few degrees. This margin of error is astonishingly small, more than sufficient for ocean navigation where the goal is to maintain a general westerly or northerly heading over many days. The experiment proved two critical things. First, it demonstrated absolute feasibility. The physics works perfectly in a real-world maritime environment. Second, and perhaps more importantly, it highlighted the profound human skill involved. The crystal does not give an answer, it gives a clue. Interpreting that clue correctly requires patience, practice, and a deep, almost intimate familiarity with the tool. It is an act of partnership between the navigator and the stone. This modern voyage did not discover a Viking sunstone, but it did something equally valuable. It transformed a theoretical possibility into a practical reality, showing us that the saga descriptions were not just poetry, but potentially precise technical accounts. It gave us a glimpse over the shoulder of a Viking navigator, watching as he squints at a piece of clear rock, finding his way in a world of gray. Yet, even with this experimental success, a shadow of doubt remains for some scholars, centered on a single, persistent question. Despite the compelling modern experiments, a chorus of scholarly skepticism remains. The central challenge is a profound and frustrating one, an absence at the very heart of the story. To date, not a single crystal has been discovered in a definitive Viking navigational context. No sunstone has been found nestled in the remains of a longship, placed in a chieftain's burial, or stored in a workshop beside tools for sail-making. For many archaeologists, this is not just a missing piece, it is a deafening silence. Physical evidence is the bedrock of their discipline, and without it, the sunstone remains a beautiful theory suspended in mid-air. Critics point out that the sagas themselves are fragile reeds to lean on. The single clear reference to a solarstein exists in a literary text, a story meant to entertain and convey cultural values, not to serve as a technical manual. Could the sunstone be a later interpolation, a detail added by a scribe familiar with different navigational tools? Or perhaps it was always a metaphor, a symbolic object representing wisdom and clarity rather than a literal piece of kit? The ambiguity of the old texts leaves the door wide open for these interpretations. Beyond the historical record, there are practical physical doubts. The method relies on detecting patterns in polarized light, but what happens under the densest maritime conditions? A thick, woolen blanket of fog or a low, heavy cloud layer can scatter light so completely that the polarization pattern becomes too weak and chaotic for any crystal to read. Could a navigator truly depend on a tool that might fail him during the very storms and fogs that pose the greatest danger? Furthermore, mastering the use of such a crystal requires significant training and ideal conditions. On the heaving deck of a ship in a choppy sea, with cold, tired hands and eyes strained from staring at the featureless horizon, could even the most skilled navigator achieve the precise, steady observations needed? These are not trivial objections. They force us to confront the romantic image with gritty reality. A balanced view must acknowledge the sunstone for what it currently is, a brilliant and plausible hypothesis, but not a settled historical fact. This uncertainty, however, is not a weakness in the story. In many ways, it is the source of its enduring power. The lack of a smoking gun, that one perfect artifact, is what keeps the mystery alive. It transforms the sunstone from a simple answer into a lingering question, an invitation to keep looking, to keep testing, and to marvel at the possibility that our ancestors might have harnessed a hidden property of light to conquer the greatest wilderness on Earth. The search itself becomes a testament to human ingenuity, reminding us that history's most fascinating secrets are often those just beyond the edge of proof. The line between a tool and a talisman can be beautifully thin. For the Viking navigator, the Sunstone was almost certainly more than a clever piece of mineral technology. It existed at a powerful intersection where practical function met profound spiritual belief. In the Norse worldview, the natural world was alive with agency and divine presence. The sun was not merely a celestial body, it was Sol, a goddess chased across the sky by wolves. The sea was the realm of Aegir, a temperamental giant. To venture into these domains was to engage directly with these powers. A crystal that could reveal the hidden sun would have been seen as more than a lens. It would have been a key, a conduit to divine knowledge. It is easy to imagine the sunstone being associated with Freya, the god of fertility, sunshine, and fair weather, a deity whose favor would be paramount for a safe and prosperous voyage. Holding the stone aloft was not just a technical act, it was a form of communion, a ritual request for clarity from the very forces that controlled the light and the seasons. This object then became a sacred anchor in the terrifying vastness of the North Atlantic, where a single mistake could mean a cold and lonely end. The sunstone offered a double reassurance. It provided a physical bearing drawn from the sky, and it served as a tangible symbol of hope, a piece of the sun's power held in the hand, a promise that light would always triumph over the overwhelming darkness of the sea and the storm. This blending is crucial to understanding the Viking mind. They did not compartmentalize their world into science and religion as we often do. A successful voyage required sound shipbuilding, skilled seamanship, accurate navigation, and the favor of the gods. All were part of a single, integrated system for survival. The ritual of using the sunstone, the careful rotation, the patient observation, the moment of recognition when the crystal darkened, all of this would have been steeped in ceremonial significance. It was a focused practice that centered the navigator, aligning his intention with the hidden order of the cosmos. The stone was a physical prayer for a safe passage, its functional success seen as a sign of divine approval. This perspective transforms our understanding of the artifact. It moves from being a hypothetical piece of lost technology to a potential keystone of a maritime culture's entire worldview. It reminds us that for our ancestors, the most advanced tools were often those that served both the hand and the spirit, bridging the gap between the measurable world and the mysterious forces they believed guided it. The legacy of such an object, therefore, is not merely one of historical navigation, but of a holistic way of being in a world that was both fiercely practical and deeply enchanted. This fusion of technology and belief was not unique to the Norse. The drive to navigate the open ocean is a story written across the entire planet, a testament to human ingenuity blooming in isolation. Each great seafaring culture developed its own language for speaking to the sea, a toolkit crafted from the specific challenges and clues of their home waters. To truly appreciate the sunstone's potential place in history, we must glance at these other remarkable systems. Far to the south, in the vast Pacific, Polynesian voyagers performed feats of navigation that still inspire awe. They sailed across thousands of kilometers of open water in double-hulled canoes, reaching the most remote islands on Earth. Their mastery did not come from a single tool, but from a profound, holistic literacy of their environment. They memorized the star compass, the rising and setting points of hundreds of stars, using them as fixed celestial pathways. They learned to read the ocean itself, feeling the subtle refraction of swells as they bounced off distant islands, interpreting long, rolling waves that spoke of land beyond the horizon. They watched the flight patterns of birds, knowing certain species would fly out to fish at dawn and return to land at dusk, revealing the direction to safety. Their knowledge was a living, oral encyclopedia passed down through generations of master navigators, who could sense their position by the feel of the waves beneath the hull and the taste of the wind. Meanwhile, in the Indian Ocean and the Arabian Sea, Arab and Persian traders perfected a different approach, one of elegant mathematical precision. Their key instrument was the camel, a simple wooden rectangle with a knotted string. The navigator would hold the camel at arm's length, aligning its top edge with the North Star and its bottom edge with the horizon. By sliding a knot along the string until it reached his teeth, he could measure the star's angle, its altitude above the sea. This angle directly corresponded to a latitude, a specific east-west line on the globe. Once the desired latitude was found, a sailor could simply sail east or west along that celestial highway until he reached his destination. This method, known as latitude sailing, traded the complexity of longitude for a beautifully simple guarantee: you would eventually hit your target coast. Placed beside these systems, the suspected Viking method stands out for its unique physical principle. The Polynesian way was an art of deep environmental observation. The Arab camel was a tool of angular measurement, of geometry. The sunstone, if it existed as theorized, was something else entirely, a tool of optical filtering. It did not measure an angle or follow a bird. It decoded a hidden property of light scattered through the atmosphere. This polarimetric approach is what makes it so singular in the annals of ancient navigation. It suggests a different kind of observation, one that looked not at what was visible in the sky, but at the very quality of the light itself. Each of these brilliant systems emerged as a direct conversation with a specific environment. The star-rich, island-dotted Pacific fostered celestial and wave reading. The predictable monsoons and clear desert skies of the Arab world favored stellar altitude measurement. And the perpetually cloud-shrouded, high-latitude North Atlantic may have pushed its sailors toward a solution that could pry direction from a featureless gray dome. This global perspective does not diminish the Viking achievement, it elevates it. It shows that the human need to explore summoned different forms of genius from different corners of the world, each perfectly adapted to its own slice of the impossible sea. They all asked the same desperate question, where are we? And each found a breathtaking answer written in the stars, the waves, or the light. The crystal's true power was unlocked only within a vast library of memory. A Viking navigator's mind was his most essential instrument, a living chart filled with details passed down through generations of whispered lessons. This was the art of the Leithanga, the sailing route, a complex sequence of environmental signposts committed to memory. A master navigator did not just know a direction, he knew a story. He knew that 3 days sail west of a certain headland, the sea would take on a colder, greener hue, signaling a deep channel where whales often traveled. He remembered that a specific species of tern, seen flying in a determined line at dusk, always pointed toward the nearest land, even if it lay beyond the horizon. He could recognize the subtle change in swell patterns as they reflected off a distant, unseen island. A gentle, rebounding wave felt more than seen through the ship's timbers. The color of the water, the types of floating seaweed, the behavior of clouds on the horizon, all were pages in this unwritten manual, and at night when the clouds parted, they turned to the stars. The North Star, Polaris, was their celestial anchor, a fixed point around which the entire sky appeared to slowly turn. Unlike the sun, its position changed very little through the night or across the seasons, offering a steady northern reference. Other constellations served as seasonal clocks and guides, their rising and setting marking not just the hours, but the progression of the sailing year. This knowledge was not acquired from a book, but absorbed through years of apprenticeship, a sacred trust between an experienced captain and his chosen student. It was a holistic science of observation where every sense was engaged. In this context, the Sunstone was not a standalone magic device. It was a specialized key for a specific, difficult lock. On most voyages under mixed skies, the traditional methods of the Leithanga would suffice. But when a dense, persistent overcast blanketed the world for days, erasing both the sun and the stars. That is when the crystal would be drawn from its pouch. It served as a backup system, a way to retrieve one crucial piece of data, the solar bearing, when all other celestial references had vanished. Its value lay in its integration into this broader system. A reading from the stone was cross-checked against the remembered feel of the current, the expected bird life, the depth of the water if they could sound for it. It was one voice in a chorus of natural clues. The navigator's genius was in synthesizing all this information, weighing the crystal's testimony against the whispers of the sea and the map in his mind. This paints a far richer picture than a simple tool. It reveals a navigational culture of profound adaptability and resilience, where technology did not replace deep environmental literacy, but supported it, ensuring that even when the sky went silent, the journey could continue. Their greatest voyages unfolded under a friendlier sky. The Viking Age did not happen in a climatic vacuum. It was cradled by a period of unusual planetary warmth, now known as the medieval warm period. For roughly 3 centuries, from around 950 to 1250 of the Common Era, global temperatures rose just enough to rewrite the rules of the North Atlantic. This was not a tropical transformation, but a crucial moderation. Sea ice retreated further north, opening corridors that had been choked with impassable flows for generations. Storm tracks shifted, offering longer stretches of more predictable weather, those precious windows of calm a sailor needed to attempt an open ocean crossing. The sailing season itself grew longer. This climatic anomaly was the silent, indispensable partner to Viking ambition. It turned the impossible into the merely perilous. Think of it as the stage being set before the actors could perform their most daring scenes. The settlement of Iceland, the colonization of Greenland, and the fleeting contact with the shores of North America, these milestones all fall squarely within this warm window. The navigational genius we have been exploring, whether through sunstone or star lore, was a technology that flourished because the environment allowed it to. The milder conditions meant fewer days of total white-out fog or hurricane-force winds that would render any crystal useless. It meant more frequent breaks in the cloud cover to calibrate those tools and to see the stars. The very seas they crossed were, for a time, slightly less vengeful. This context is vital. It helps explain the explosive timing of their expansion. For generations, the Norse had been masterful coastal sailors, but the leap into the deep ocean required more than courage and skill. It required an opportunity. The medieval warm period provided that opportunity. It created a navigable world where their accumulated knowledge could be tested and extended over unprecedented distances. The suspected sunstone, then, was not invented in response to a sudden crisis, but refined within a period of expanding possibility. It was a tool for maximizing the advantage granted by a changing climate. This perspective shifts the narrative from one of sheer human willpower to a more complex interplay between people and their planet. Their golden age of exploration was in part a gift from the climate itself. But like all gifts, it was not permanent. The window of opportunity that had swung open so invitingly would, in time, begin to close. The warmth that had cradled their voyages would not last forever. As the 13th century drew to a close, a great chill began to descend upon the North Atlantic, a climatic shift that would usher in what we now call the Little Ice Age. This was not a single cold winter, but a profound and prolonged cooling that lasted for centuries. Its effects were catastrophic for the Norse way of life in the far west. The sea ice returned with a vengeance, creeping further south each year, blocking the vital shipping lanes between Iceland, Greenland, and Europe. Growing seasons in Greenland shortened drastically, making it impossible to sustain the livestock and agriculture the settlements depended upon. The weather grew more violent and unpredictable, with fiercer storms and longer periods of dense, impenetrable fog. the very environmental clues that navigators had relied upon became scrambled or disappeared entirely under a permanent shroud. The window of opportunity slammed shut. The settlement in Greenland, isolated and starved of supplies and contact, eventually faded from history. With it, the specialized knowledge required for transatlantic travel, including the precise use of tools like the sunstone, likely dwindled and was forgotten in Scandinavia, rendered obsolete by a changing world and the later adoption of the magnetic compass. The legend persisted in the sagas, but the living practice, the intimate hand knowledge of the crystal's language, was lost to the cold. This climatic bookend to the Viking Age is a powerful reminder that human history is never separate from the planet's own story. Their era of exploration was born from a unique alignment of technology, courage, and a temporarily forgiving climate. When that alignment broke, so too did the thread connecting Europe to the distant shores their ships had once touched. The sunstone, if it existed, became a relic of a warmer past, a tool for a sky that had changed. Yet, just as the stone itself was lost to time, the quest to understand it was only beginning, moving from the realm of historians into the precise world of modern physics. The legend of the sunstone has long since sailed out of the sagas and into our collective dreams. This crystal compass now holds a vibrant life in modern stories, a symbol of lost wisdom and ancient secrets. You can find it gleaming in the pages of best-selling historical novels, where a hero might clutch it during a storm to save the fleet. It appears as a powerful artifact in fantasy video games, a magical item that unlocks hidden paths or reveals invisible enemies. Documentaries feature dramatic reenactments of its use, with moody music and actors squinting at a crystal against a CGI sky. These portrayals are captivating, and they serve a wonderful purpose. They keep the mystery alive in the public mind. They transform a dry archaeological hypothesis into a living, breathing idea that sparks curiosity and wonder. A teenager playing a game might pause and think, wait, was this a real thing, and suddenly fall down a research rabbit hole. In this way, popular culture becomes a gateway to history, drawing people into a story they might otherwise never encounter. Yet this romantic embrace comes with a subtle cost. The line between evidence-based theory and pure fantasy can become beautifully, dangerously blurred. When the sunstone is shown working with flawless, magical precision under any condition, it simplifies a deeply human story of struggle, skill, and uncertainty. The real navigator's patient calibration, his moments of doubt, his reliance on a dozen other clues, these complexities are often smoothed away for the sake of a clean narrative. The tool can become a talisman, its power inherent in the crystal itself rather than in the generations of hard-won knowledge required to interpret its faint signal. This shapes a public perception where the Viking achievement risks being seen as something mystically gifted rather than ingeniously earned. It is the difference between believing they had a magic GPS and understanding they built a sophisticated analog system for reading the world. This presents a fascinating challenge for historians and scientists. Their task is to communicate a nuanced, evidence-starved reality in a world saturated with compelling fiction. They must honor the genuine wonder of the idea while carefully grounding it in the dirt and ice of archaeology, the physics of light, and the cautious language of academic research. It is a push and pull between inspiration and integrity. The goal is not to ruin the fun, but to deepen the appreciation. By separating the plausible tool from the magical plot device, we can see the Vikings not as fantasy heroes with mystic crystals, but as real-world problem solvers of staggering resilience. Their true ingenuity lies in the possibility that they observed a hidden property of light, devised a method to harness it, and integrated it into a vast body of environmental knowledge, all to solve the most practical of problems: how do we get home? That authentic story of human creativity confronting a monumental challenge is in many ways more impressive than any magic. It connects us to them not through legend, but through shared intellect. So the next time you see a sunstone glowing in a game or described in a novel, let it be a reminder not of a lost enchantment, but of a lost science waiting just beneath the surface of the story, inviting us to look closer. The silence of the soil is perhaps the loudest argument against the sunstone. For all the compelling sagas and successful modern experiments, archaeology has yet to deliver the one piece of evidence that would settle the debate: a crystal found in a clear navigational context. This absence hangs over the entire theory, a ghost in the historical record. If these tools were as vital and widespread as the hypothesis suggests, why have we not unearthed a single one nestled beside a shipwright's tools or resting in a navigator's grave? This question is not a dismissal, but a crucial part of the mystery, and it leads us down several plausible paths. The first possibility is one of simple material reality. Imagine a sunstone not as a gleaming gem on a chain, but as a practical working tool. It might have been mounted in a simple wooden frame, perhaps with a handle for easy gripping against the sky, or sewn into a leather pouch attached to a sailor's belt. Wood and leather are organic materials that decay rapidly in most soils, especially in the damp, acidic conditions common across Scandinavia and the North Atlantic. After centuries, all that might remain in the ground is a small, unremarkable crystal, loose and disconnected from any context that would signal its purpose. To an archaeologist excavating a settlement, it could easily be mistaken for a decorative bead, a gaming piece, or a raw mineral specimen traded for its beauty rather than its function. Without that telltale mounting or its placement beside other navigational gear, its true story is lost. Another consideration is value and reuse. A high-quality, clear piece of Iceland spar or cordierite was not a trivial object. It was a valuable piece of raw material. If a navigator's sunstone was cracked or damaged, the crystal itself might have been carefully saved and repurposed, perhaps recut for jewelry or traded onward. In a culture skilled in resourcefulness, nothing useful was simply thrown away. Furthermore, these stones may have been rare, curated objects, passed down from master to apprentice within a family or a guild of sailors. Such an heirloom would seldom enter the archaeological record through casual loss. It would be carefully kept in use for generations, and if it finally left possession, it might be through deliberate trade far from its home, further scattering any trail. There is also the sobering possibility of misidentification by early archaeologists. In the 19th and early 20th centuries, the focus of Viking archaeology was often on grave goods, weapons, and obvious treasures. A small, translucent crystal in a settlement layer might not have been considered significant, catalogued simply as quartz or an unworked mineral. Modern researchers, armed with the sunstone hypothesis, are now re-examining old museum collections with new eyes, looking at bags of uncategorized stones from decades-old digs, wondering if the key artifact has been sitting in a drawer, quietly waiting for its story to be understood. This ongoing scrutiny is a testament to how a single idea can revitalize an entire field. The absence, therefore, is not a dead end, but a driver of deeper inquiry. It forces us to refine the question. We are not just looking for a crystal, we are looking for the ghost of its use, the shadow it left on the culture and technology of its time. The search continues not only in the ground, but in the subtle rereading of everything we have already found. The crystal's guidance would have been meaningless without the mind that held it. Navigating by sunstone was not a passive act of looking, but an active state of being, a form of disciplined meditation practiced on the heaving deck of a ship. Imagine the mental fortitude required. For days, sometimes weeks, the world is a monochrome sphere of gray sea meeting gray sky. Every wave looks the same. Every cloud formation offers false hope. In this sensory deprivation chamber of the open ocean, the navigator had to maintain a razor-sharp focus, resisting the despair that monotony breeds. His entire world narrowed to a few key inputs: the feel of the wind on his cheek, the rhythm of the swell beneath the hull, and the faint signal from a piece of rock in his hand. Patience was not a virtue, it was a survival skill. He might wait for hours for a slight thinning in the cloud cover, a momentary brightening that would allow him to calibrate his stone or confirm a bearing. This was not idle waiting, but vigilant waiting, a continuous low hum of attention. Then came the moment of decision, the act of trust that defines leadership at sea. The crystal gives its subtle cue, a darkening, a clarification of a double image. This reading might contradict his gut feeling, his instinct honed by years of experience. Perhaps the swell feels like it's coming from the north, but the stone insists the sun is southwest. In that moment, he had to silence the voice of instinct and place his faith and the lives of his crew in the silent testimony of polarized light. This is the profound psychological pivot, the courage to believe in an invisible pattern over the immediate testimony of the senses. It is a leap into scientific rationality made centuries before the scientific method was formally defined. The sunstone became the focal point for this entire cognitive ritual. The act of raising it, of rotating it slowly with deliberate hands, centered the navigator. It was a physical routine that channeled a scattered awareness into a single, precise task. Through this ritual, he filtered out the panic of the unknown, the fatigue of the body, the complaints of the crew. His hyper-awareness of the environment, the shift in wind feel, the subtle new pattern in the swell, all these data points were processed in relation to that one anchor point, the bearing from the stone. This mindset transforms the navigator from a mere technician into an artist of perception. He was not just reading a tool, he was conducting a silent symphony of clues, where the crystal provided the central melody around which all other harmonies, the wind, the waves, the wildlife, were arranged. His mind was the instrument that integrated it all, making the critical judgment calls when clues conflicted. To lose this focus, to succumb to doubt or frustration, was to become truly lost. The sunstone, therefore, was as much a psychological tool as a navigational one. It provided a tangible ritual to ward off the creeping uncertainty of the featureless deep, a way to impose order on chaos, and a physical symbol of the unwavering attention that the sea demanded. This mental discipline, forged in the grey Atlantic, may be the most enduring legacy of their voyages, a reminder that the greatest explorations always happen first in the quiet, steadfast space of the human mind. That unwavering focus at sea translated directly into wealth and power on land. The legendary voyages of discovery were not merely feats of courage, they were the vital supply lines for an entire economic system. The Norse world was a network, a web of connections stretching from the bustling markets of Scandinavia to the remote outposts of Greenland. What held this web together was not just shared culture, but the reliable movement of goods across some of the most treacherous waters on Earth. This is where the practical value of a tool like the sunstone becomes starkly clear. It was not simply about finding new lands, it was about consistently, safely, returning from them with cargo. The most prized commodities in this trade were products of the harsh northern environment, luxury items that could command fortunes in European courts. Walrus ivory, with its fine grain and pure white color, was carved into exquisite chess pieces, religious objects, and decorative items. Thick furs from Arctic foxes and bears provided warmth and displayed immense status. Soapstone, easily carved into durable cooking pots and lamps, was a practical necessity for settlements with limited metal. Transporting these goods from the remote harvesting grounds to distant markets was an operation of immense risk and potential reward. A single ship lost to a navigational error meant more than a tragic loss of life. It represented a catastrophic financial blow. An entire season's harvest of ivory could vanish beneath the waves, a trading family's wealth erased, and a settlement's crucial supply line severed. In this context, any technology that significantly reduced the risk of getting lost was not just a clever gadget, it was a direct economic multiplier. A tool that could pull a bearing from a cloudy sky meant a captain could maintain his course even when visual landmarks disappeared for days. It meant he could sail closer to the optimal, direct route with greater confidence, rather than being forced to cautiously hug coastlines and add weeks to a journey. This reliability protected the three most valuable assets of the Norse economy: the cargo itself, the skilled sailors who manned the ships, and the integrity of the trade routes that formed the backbone of their society. The Sunstone, therefore, shifts in our understanding from a romantic tool of exploration to a foundational piece of commercial infrastructure. It was the kind of innovation that would have been guarded not just as a navigational secret, but as a trade secret. A chieftain or merchant who controlled such reliable means of navigation held a profound advantage. He could plan larger cargoes, ensure better returns for his backers, and establish his reputation as a dependable link in the network. This commercial lens helps explain why such a tool might not appear in every fishing boat. It may have been specialized technology for the long haul, the open ocean crossings that carried the highest value and the highest stakes. Its development and refinement were likely driven as much by the demands of commerce as by the spirit of discovery. The flow of ivory and furs south, and the flow of grain, iron, and timber north created a circulatory system for the Norse world. A tool that made that circulation more predictable was nothing less than a technology of empire, quietly enabling the cultural and economic connections that defined a civilization spread across the roof of the world. The quest to find direction from the sky did not end with the Vikings. The principle they may have harnessed, that of locating the sun through indirect means, echoes through the centuries in the tools that followed. While the sunstone itself vanished from common use, the fundamental problem it addressed remained, driving innovation forward. The next great leaps in celestial navigation came not from crystals that filtered light, but from instruments that measured angles with breathtaking precision. Consider the Astrolabe, a complex brass disc etched with star maps and time scales, used for centuries by astronomers and sailors. Then came the sextant, its mirrored arms allowing a navigator to measure the exact angle between the horizon and a star or the sun. On the surface, these brass and glass devices seem worlds apart from a simple chunk of calcite. But at their core, they are all solving the same ancient equation, using the heavens to determine position on Earth. The Viking method, if our theory is correct, was a form of polarimetric navigation, finding the sun by reading the polarization of its scattered light. The astrolabe and sextant rely on goniometry, the precise measurement of angles. The goal was identical, only the mechanism evolved. We can see a conceptual lineage here, a thread connecting the intuitive act of holding a crystal to the sky to the calculated ritual of aligning mirrors and reading finely engraved scales. It is the story of humanity refining its questions, moving from where is the sun to exactly how high is it above the horizon, and what does that precise number tell me about my place on the globe. The sunstone stands as a kind of brilliant prototype, a first draft of a solution written in mineral and light. Its loss, perhaps due to climatic change or the adoption of the magnetic compass, meant that later cultures had to reinvent the wheel of celestial navigation, but they built a chariot. They formalized the intuition, mathematized the observation, and created instruments that could be standardized and taught. Yet in that very process, something intimate was also lost. The Viking navigator's tool was an extension of his personal skill and environmental awareness, a partnership. The sextant, for all its accuracy, is a more detached device, its reading separate from the feel of the sea or the color of the clouds. This evolution shows our relentless drive to objectify knowledge, to take a fragile, personal art and forge it into a reliable, repeatable science. The sunstone represents a moment in that long journey, a whisper from an earlier chapter in our species' endless conversation with the stars, reminding us that every advanced tool begins as a simple, desperate question asked of the sky. This archetype of a guiding stone may have been whispering across Europe long before Viking sails caught the wind. If we listen to the wider family of Indo-European myths, we hear echoes of the sunstone in the legends of cultures separated by mountains and seas. The ancient Celts, for instance, spoke of the Lia Fail, the stone of destiny, which was said to cry out when the rightful king of Ireland stood upon it. While not a navigational tool, it shares that core idea of a stone that reveals truth, that connects to a deeper, almost divine order. In Slavic folklore, tales sometimes speak of a latter, a mythical stone at the center of the world, endowed with healing and magical properties, often associated with the power of the sun. These are not instructions for sailors, but they are fragments of a shared symbolic language where certain stones act as conduits for cosmic power, clarity, and legitimacy. This pattern suggests the Viking sunstone might be a particularly practical, maritime-focused version of a much older and broader idea. It takes a mythological motif, the stone that holds or reveals light, and engineers it into a working instrument. The Norse, living at the harsh edge of the navigable world, had a desperate, concrete need for celestial guidance. Their culture likely shaped this widespread archetype into something specific and functional, a tool that answered the relentless question of the North Atlantic. This connection transforms our understanding. It means the sunstone was not an isolated, bizarre invention, but a brilliant adaptation of a deep cultural memory. Various ancient peoples looked at special stones and saw vessels for power or prophecy. The Vikings, perhaps uniquely, looked at such a stone and saw a way home. They took the symbol and gave it a bearing, turning poetic metaphor into a life-saving piece of applied physics. This journey from myth to mechanism shows how human innovation often works. It begins with a story, a belief about how the world operates, and then, under the pressure of necessity, that story is forged into a tool. The sunstone, therefore, sits at a fascinating crossroads. It is a piece of technology born from a legend, a scientific instrument that never fully shed its mythological skin. It reminds us that for our ancestors, the line between the practical and the sacred was often invisible, and the greatest tools were those that served both the hand and the human spirit's need to find meaning in the vast and unknown sky. Yet the story of the sunstone is not one for the history books alone. It is a mystery actively being pursued with tools the Vikings could never have dreamed of. The question of its existence now sits at the cutting edge of 21st century science, where researchers are deploying methods that feel like something from a detective novel. One of the most promising frontiers is the microscopic analysis of known Viking artifacts. Scientists are now using advanced three-dimensional scanning technology to examine objects like the Uunartoq disc, wooden bearing dials, and even simple pieces of polished wood, searching for telltale signs of use that have been invisible to the naked eye for 1,000 years. Could a wooden frame that once held a crystal have left a unique pattern of microscopic wear, a specific polish or set of grooves that matches the repeated rotation of a smooth stone? Finding such a pattern on an object from a confirmed navigational context would be a monumental step forward, providing indirect but powerful physical evidence. Another line of inquiry involves the stones themselves. Using a technique called isotopic fingerprinting, geologists can analyze the precise chemical signature of a piece of Iceland spar. Every geological source, every mine, has a unique isotopic blend, like a mineral DNA. If researchers can build a database of these signatures from known ancient quarries, they could then take unidentified crystal fragments found at Viking sites and trace them back to their source. Finding a shard of Iceland spar from a specific Icelandic mine in the workshop of a Norse shipwright would be a compelling piece of the puzzle, placing the right material in the right hands. Beyond the physical evidence, digital technology is opening new windows into the past. Complex computer simulations can now model entire Viking voyages, factoring in historical weather data, ocean currents, and most intriguingly, accurate models of polarized light under thousands of different cloud conditions. Researchers can run virtual ships across a digital North Atlantic, testing how a crew using a sunstone at specific intervals would fare against one relying only on traditional methods. These simulations can show us not just if the tool worked, but how often it would have been useful and what margin of error it might have provided in the chaotic real world of an ocean crossing. Every new archaeological excavation in the Norse world, from a newly discovered shipwreck resting in the deep to a forgotten farmstead on a Greenland fjord, now carries this added potential. Each trowel of soil turned could reveal the one artifact that changes everything, a crystal nestled in a leather pouch beside a carved wooden dial, waiting for its story to finally be told. The search has evolved from interpreting old texts to reading the invisible stories etched in atoms and light, a testament to our enduring fascination with how they found their way. The most convincing case for the Sunstone is often made not in a laboratory, but in the hands of a curious visitor. Museums and historical societies around the world have begun integrating replica sunstones into their educational programs, transforming theory into a tangible, personal experience. These are not static displays behind glass, but active workshops where people are invited to hold a piece of Iceland spar, step outside on a cloudy day, and try the ancient technique for themselves. The effect is immediate and profound. Abstract concepts of polarized light and celestial navigation suddenly become a physical sensation, a squint of the eye, a slow rotation of the wrist, a moment of recognition when the crystal's secret signal finally clicks. For a student or a history enthusiast, this connection bridges a 1,000-year gap in an instant. They are not just learning about Viking navigation, they are momentarily practicing it, feeling the same quiet challenge of patience and observation that a Norse sailor would have faced. This hands-on approach makes history visceral, turning audiences from passive listeners into active participants in the mystery. These public demonstrations serve a dual purpose beyond simple education. As instructors guide groups through the process, they gather invaluable informal data. They see how easily modern people with no prior training can grasp the technique. They note the common points of confusion, the weather conditions that make the signal too faint, and the practical questions that only arise when you are holding the object. A visitor might ask, how do you keep it steady on a windy ship? Or what do you do if your hands are cold and numb? This continuous, real-world feedback from thousands of participants becomes a kind of living research, contributing subtle, practical insights to the broader experimental dialogue about the tool's everyday viability. It tests the human element of the equation that pure physics cannot. These programs democratize the investigation, allowing everyone to become a citizen scientist for an afternoon, weighing the evidence not with a textbook, but with their own senses. In doing so, they keep the story alive and evolving, ensuring that the Sunstone remains a question we explore together, one curious glance at a cloudy sky at a time. Our fascination with the past must always be tempered by thoughtful perspective. Enthusiastically rebuilding a Viking sunstone is one thing, but we must be careful not to rebuild the Vikings themselves into something they were not. This is where a critical idea enters the conversation, the concept of Viking exceptionalism. It is a tempting narrative to frame them as uniquely brilliant, as lone pioneers of science in a so-called dark age. The truth is far more interesting and far more human. The Norse world was deeply connected, a vibrant part of a global medieval tapestry of trade, ideas, and innovation. Their suspected navigational breakthrough did not happen in a vacuum. While they may have been the only culture in the North Atlantic to potentially use polarimetric navigation, They were just one of many cultures solving the universal human problem of wayfinding with the tools their environment provided. Placing the Sunstone within this global context does not diminish the achievement, it elevates it. It becomes a brilliant local answer to a worldwide question, a testament to the diversity of human ingenuity. When we isolate their story, we risk creating a myth of isolated genius. When we connect it, we see a shared saga of adaptation, where Polynesian star readers, Arab astronomers with their camels, and Norse sailors with their crystals were all different chapters in the same epic book of exploration. This broader view fosters a deeper respect, not just for one group, but for the incredible capacity of people everywhere to observe, experiment, and overcome. With this respect comes a profound responsibility. The symbols and stories of the Norse past have, unfortunately, been co-opted and twisted by modern extremist movements for hateful ideologies they never represented. This places an ethical duty on anyone sharing this history, from documentarians to educators to enthusiasts like us. We must be vigilant in separating the authentic, complex historical culture from these toxic distortions. The real Viking Age was about exploration, trade, family sagas, and yes, conflict, but it was not a model for the bigoted narratives these groups promote. Our discussion of a sunstone, a tool of connection and survival, must consciously stand apart from that darkness. We celebrate the ingenuity, not a false purity, the clever adaptation to the sea, not a myth of supremacy. By focusing firmly on the technology as a human achievement, on the navigator's skill as a universal testament to patience and observation, we reclaim the narrative. We ensure our fascination fuels curiosity and cross-cultural understanding, not division. The true legacy of such a tool is not found in exclusion, but in its power to remind us of a simple, beautiful truth. Faced with the same immense ocean, under the same hidden sun, different peoples, in their own ingenious ways, learned to listen to the light, the waves, and the stars, and found their path forward together. A simple crystal now represents something far greater than a navigational tool. It has become an icon of human ingenuity, a timeless lesson in solving impossible problems with the resources you have at hand. In our world of satellite networks and instant digital answers, the Sunstone story resonates with a quiet but profound power. It speaks directly to scientists and engineers who face modern puzzles, reminding them that breakthrough solutions often come from observing the fundamental principles of the natural world with fresh eyes. It inspires adventurers and explorers who push into physical and intellectual frontiers, showing that the most reliable guide can sometimes be a deep understanding of the environment itself, not just the technology we bring to it. This ancient object challenges our dependence on complex systems, asking us to remember the foundational skills of observation, patience, and adaptation. The lesson is not to abandon advanced tools, but to cultivate the underlying wisdom that makes their use meaningful. When a GPS signal fails or a system goes dark, the Sunstone's legacy is the mindset it represents, the ability to look at a gray sky or a trackless sea and still find a way forward by listening to the subtle language of the world. It teaches resilience, the kind built not on brute force, but on creativity and a respectful dialogue with nature's hidden patterns. This story, 1,000 years old, feels urgently modern. It tells us that our greatest innovations are often those that work with the world, not against it, harnessing a simple, elegant truth to illuminate a path through the unknown. The enigma of the Sunstone is a map of how we understand the past. It charts a course from the poetry of ancient sagas, through the silent testimony of wooden artifacts, and into the precise laws of physics that govern light itself. We have followed this trail across a conceptual ocean, from the first tantalizing mention of a solarstein to modern hands holding a crystal against a cloudy sky. What emerges is not a single, definitive answer, but but something perhaps more valuable, a profound appreciation for the layers of human ingenuity. The Vikings did not need to understand polarization as a scientific term to harness its effect. They needed only to observe, to experiment, and to trust a consistent signal from the natural world. This practical genius, this ability to build a bridge between observation and application, is the true treasure uncovered by this search. While the physical sunstone may still lie buried, waiting to be found, its story is already unearthed in the compelling convergence of evidence. It stands as a brilliant hypothesis, a monument to what might have been, and a challenge to our imagination. The very fact that we are still debating it, testing it, and marveling at its elegance centuries after the last Viking longship sailed is a testament to its power. This stone, real or symbolic, ultimately guides us to a deeper truth about our species. It speaks to that relentless drive to push beyond the horizon, to solve the puzzle of where we are, using whatever tools the earth and sky provide. It reminds us that discovery often begins not with complex technology, but with a curious mind and a willingness to listen to the quiet whispers of the world. Let this mystery inspire your own perspective. Look at the clouds not just as weather, but as a canvas of hidden information. See in a simple crystal the potential for extraordinary insight. What other secrets from our past are waiting to be read in the language of light, or wind, or wave? The journey of understanding is never truly over. We would love to hear your thoughts on this ancient enigma in the comments below. If you enjoyed this voyage into a hidden chapter of history, subscribe to join us as we explore more lost technologies and forgotten wisdom from the depths of time.